Hello everyone, in this video we're going to talk about time value of money, which is the basis of engineering economic analysis. So let me start by asking you these two questions. The first one is, would you rather receive $1,000 today or $1,000 a year from today? I'm guessing you would rather have $1,000 today. And the reason is because in the meantime, in the next year, you could increase the value of $1,000 by simply putting it in a savings account and earning interest on that. So that's why you're probably going with that option. But the second question is asking, would you rather receive $1,000 today or $2,000 a year from today? Well, this is a different question. Now you have to think about, is that additional $1,000 that you're receiving if you wait for another year is enough for you? Is that representing your time value of money or not? And I'm quite frankly, really depends on how greedy you are. I would probably go with the $2,000 a year from today, because in a year I'm doubling that amount, and that basically means 100% return. So let's put everything into perspective. What we're doing here by asking these questions is we can realize that money can be essentially rented in roughly the same way that one rents an apartment. When we're renting an apartment, we're essentially giving that space and we're charging money, and at the end of the period, we're getting the space back. So the rent is an analogy for the interest rate when you're renting your money. And money has earning power. And if you own money and someone needs it, you can loan it to them and charge them interest. The interest rate you charge them is based on your time value of money. So there is an interest rate here that represents your time value of money. In this case, the interest rate or the time value of money was 100%, because you're doubling the amount. So the value of a given sum of money does not only depend on the amount of money, it also depends on the point in time. When exactly do you have that money? Not only the amount, but also the time. And that's the point behind, quite frankly, this course. Time value of money is calculated using an interest rate. An interest rate, you can see that it also called discount rate, sometimes minimum attractive rate of return, MARR, or cost of capital. Let's look at this example here and put everything in perspective. A man borrowed $1,000 from a bank at 8%. He agreed to repay the loan in 2 end-of-year payments. At the end of each year, he will repay half of the $1,000 principal amount plus the interest that is due. Compute the borrower's cash flow. So let's start by drawing the cash flow here, cash flow diagram. At time 0, from the perspective of this man, he is receiving $1,000. Okay. And we have year 1 and we have year 2. And what we want to compute here is that how much he needs to repay at the end of each year. So at the end of year 1, he will repay half of the principal, so it is $500, plus the interest that is due. So plus some amount, and that amount is the interest on the $1,000. And interest rate is 8% yearly. So that means 8% times the money that he borrowed for that year. So that is equal to 500 plus $80, so $580 is what he will repay at the end of year 1. But what happens at the end of year 2 is that he will pay another half of the principal, another 500, and then the interest of the money that he borrowed for the second year. For the second year, he is again paying 8% interest. So 8% interest on the money that he borrowed in that time frame. In that time frame, he's borrowing $500 because he paid off the first $500. So 8% times $500. So he's paying back $540. So $540 and $580 is what he will be repaying in year 2 and year 1. So this is the cash flow of this problem. So if you were to loan a present sum of money P to someone at a simple interest rate of I for a period on n years, the total interest that you will basically earn is the sum of money that you're lending times the interest rate, your time value of money, times the duration of that, which is P times I times N. And the money that you would end up with at the end of the period is your present sum that you lend plus the interest that you earned. So P plus PIN. The important definition here is the simple interest definition, and that is the interest on the original sum only. It's a very important point because later on we'll be talking about compound interest, and that is the main difference between simple interest and compound interest. Simple interest is only on the original sum of money and not on the accrued interest. Let's look at another example here. You have agreed to loan a friend $5,000 for 5 years at a simple interest rate of 8% again per year. How much interest will you receive from the loan? How much will your friend pay you at the end of 5 years? So again, in any problem, let's start always with drawing a cash flow diagram. In this case, it's a very simple one. Time zero. From your perspective, you're giving away $5,000, and at the end of year 5, you're getting something back. We want to compute that here. So our P here is $5,000. Number of years, N, is 5 years. And interest rate is 8%, right? The total interest, to answer the first part of the problem, how much interest will you receive from the loan? The total interest will be PIN, right? You remember that, PIN. So 5,000 times 8% times 5 years. So you will receive $2,000 in interest. And the total money that you would collect here at the end of year 5 will be your principal plus interest, right? So your principal was $5,000 plus the $2,000 interest, you will receive $7,000. That's how simple interest works, and it's pretty simple. In the next video, we'll be talking about compound interest rate.